Hi, ladies and gentlemen. This is another in my series of lessons on AP statistics. We're taking up the concept starting in Unit 8 at this point. We're going to be looking at the distribution of means. So, you guys should have finished everything in Unit 7, taken the test, and be ready to work on Unit 8, okay? Due dates, 28 days. Everyone knows the rules there. I'm not even going to keep going over that anymore. Okay. What we're looking at is in the AP statistics range, we're looking at confidence interval information here. Okay? And we're looking at t distributions. And a single sample t procedure and a two sample t procedure are going to be some of the later topics that we'll talk about. Okay? So let's look at this first one, t distribution. It's very, very similar to a normal distribution that we've already been doing and done quite a bit of. So we're going to use the same procedures as we did for z values and getting that confidence interval and things like that. So it's not like it's going to be a whole lot different as far as procedures are concerned. The only difference is the degrees of freedom. The lower the n, the more the curve differs from the normal distribution curve. So if you look at it, the normal distribution curve, looks like this. Okay, the the t curve looks very similar to it, but it'll be a little bit above it out here. It'll go up to about the same mean and come out and be a little bit above it out here. Okay, and that's for very low values in n. And then as n gets bigger, this gap here starts to close a little bit, and you'll start seeing this gap going down to where they're almost right on top of each other. Basically, when you get to 30, a sample size of 30, they're basically right on top of each other, and you can't really tell them apart. It's not going to make a whole lot of difference. Okay? But this is actually a lot more common than the z distributions, the ones that we were doing with the normal curve. Why? Because in those we had to know the sigma and we had to know the mean to make it actually work. And that's of the entire population. In actuality, we can only find S bar and X bar. Those are the sample information that we've got. Then we can make estimates for mu and sigma, but they're only estimates. They're not really there. So one of the requirements here is that we do have normality. We studied this in the first semester. How do we find normality? Usually with graphs. We can put a graph up there and look at it. If the um, um, distribution graph, frequency distribution graph looks fine, you're in good shape. If that you can't really tell from that, look at the box and whisker graph. It will help you. You can see if they are normally distributed. Okay, so you see this little statement right here? We are some percentage confident that a true mean, with some context here, is between this number and this number. This is the way you have to state it on the AP test. If you don't make that statement in that format, it will get you in trouble. It won't give you full credit for it. So what we're saying is we are 90% confident that the true mean of the tested information for AP statistics tests is between 92 and 98. See how I used that? I used the real context. Whatever it is that you test that you're doing, that's what you're going to put in here for context. And you're going to make certain it makes sense. You're going to use the confidence level here. You're going to have your interval right here. So that's what you need to make sure you're stating, okay? Let me give you an example, okay? Medical researcher measures the pulse of a random sample of 20 adults, okay? The mean pulse rate is 72.69 beats per minute with a standard deviation of 3.686 beats per minute. Assume pulse rate is normally distributed. Well, you're going to have to try to prove it this time. We're just going to assume that it's true, okay? Excuse me. Okay, and compute a 95% confidence interval for the true mean of the adults. Okay, what you would say at this point is that we're 95% confident that the true mean pulse rate of adults is between 70.883 and 74.497. But how did I get that information? Well, I want to show you. I'm going to bring up my little calculator here, and I'm going to clear what's in there right now out. And I'm just going to hit uh, we're wanting to do a t-interval. That's what we're trying to find here, right? So we're going to do a stat, and we're going to go over to test, and right down here on number 8, is a t-interval, number 8. So when I press enter on t-interval, do we have the data or do we have the statistics? Well, they actually gave us the statistics here, so let's just use statistics. And on tests, that's probably what you're going to have a lot of, is just the statistics. They gave us an X bar data. They gave us their sampling information, 72.69 beats per minute. Okay? They found a standard deviation or a standard error of 3.8986. Okay? And how many people did they test? Well, they tested 20 people. Not 220,000. It's 20 people. Thank you. Calculator being mean to me. And our confidence level, they wanted a 0.95, so I'm going to put 0.95 in there. And I'm going to hit calculate. When I do that, it will come up with this same level here, 70.883, 74.479. Gave me the X bar, gave me the S bar, gave me the N back on it, but it actually calculated the T interval for us. Isn't that nice? We don't even have to go look things up in a table or anything. It does it for us, okay? That doesn't mean we get by with not having to know the formulas for it or anything else. It just means that the calculator will calculate that interval level information for us. Okay? So, having done that, I've shown you the easy way to do it. I've given you information you need to go to calculate t intervals. Have fun with it. Play with it a little bit. See what you come up with. Okay? I appreciate the fact that you guys do tell me that you're in AP Statistics. It helps me a lot. It really does. And I'll look forward to seeing you next time.